Hello and welcome to the video. So in the last lecture we learned about the equivalence relation. Okay, what is the meaning of equivalence relations? That it is reflexive, symmetric and transitive. Okay, now equivalence relation is deeply connected with the partition of a set. So before finding the relation we have to know that what is the partition of a set. Okay, partition is nothing but a collection of a sets. Okay, partition is a collection of disjoint subsets of x is a set, okay, such that union of the set is x. Okay, this is called the partition. And here are some words such that collection of disjoint subset. What is the meaning? We know that collection of subsets क्या होते हैं, okay, कि एक subsets को इकट्ठा करके collection बना दो, ठीक है. But disjoint क्या होता है? So we have to know about the disjoints. Let A is subset of x and B is also subset of x. Okay, so A intersection B equal to phi. This is called disjoint. That means they don't intersect. Okay. Now let I have a set of natural numbers. Okay. Natural numbers means 1, 2, 3, 4, and it goes on. Okay. I'll make a set E, all even numbers. Okay. And a set O, all odd numbers. Now tell me, E intersection O is what? Is phi? Why it is phi? Because there are no elements which belong in both sets. Okay, and now tell me that E intersection O is equal to n or not. It is n because 1 is there, 2 is there, 3 is there, 4 is there in the union of E and O. Okay, so we'll name it C, collection of E and O. This is a partition of natural number set of natural numbers. Okay, so this is called a partition. Now we have to find the relation between partition and equivalence relation. First of all, we have to learn about the equivalence classes. What is this equivalence class? Okay, so we'll denote equivalence class like this. Okay, now equivalence class only defined on equivalence relations. Okay, first of all, and what equivalence class contain? It contains y belongs to x, k element such that x is related to y. So every element has an equivalence class. Okay, so now let a relation x on the set 1 comma 2 comma 3. Okay, the relation is 1 comma 2, 1 comma 1, 2 comma 2, 3 comma 3, and 2 comma 1 is there, so 1 comma 2 should be there because it is equivalence relation. Okay, so what is the meaning of equivalence class of 1? So this means ki 1 is related to which elements. Okay, so you can see that 1 is related to 2, 1 is related to 2. What is the meaning of x related to y? Means x comma y should belongs to R. Okay, so here you can see that ki 1 comma 2 is there, so this set contain 2 because 1 is related to, and here you can see that 1 is related to 1, so 1 should be there in this class, and nothing else. This should be 2 comma 1. Okay, and nothing else contain in this. Okay, because 1 is related to only these two elements. Now tell me about the equivalence class of 2. Now look at here, that 2 is related to 1, so 1 should be there, and here 2 is related to 2, so 2 will be there. And now equivalence class of 3, only 3 is related to 3 and nothing else, so only 3 is there. Okay, so these are the equivalence classes. Okay, equivalence class of 1, equivalence class of 2, and equivalence class of 3. Now by these equivalence classes we can define a collection which will be a partition. Okay, so how we'll do that? From the equivalence classes we can see that the union of equivalence classes will be the whole X. Why is that? Because every equivalence class contain itself, because it is reflexive, so X comma X always in the relation. Okay, for all X. So I'll, if I union them, all the equivalence classes, then all the X's are there. Okay, so whole X can be generated. Okay, so here I know that union of all the equivalence classes X belongs to X is equals to X, because every equivalence class contain itself. Okay, X belongs to this for all X. Why is that? Because of this. Okay, because of this. now now I have to prove that the intersection of two equivalence classes are phi. Okay, so we'll prove it by contradiction. Contradiction means I'll assume that there is an element and I'll tend to a contradiction. Okay, so let Z is in equivalence class of X and Z is also in equivalence class of Y. Okay, so what is the meaning of equivalence class? That X should related to Z and Y should related to Z. Now if Y is related to Z, then Z should related to Y. Why is that? Because of symmetric. Equivalence relation are symmetric also. So Y related to Z means Z is related to Y. Okay, now from here X is related to Z and Z is related to Y. What is that meaning? This means X is related to Y. Okay, why? Because of transitivity. Similarly, so what is the meaning of X related to Y? That Y should belongs to the equivalence class of X, and Y is related to X is related to Y means that Y also related to X. Again symmetricity. Okay, so X also related to, this implies that X is identically equal to Y. ओके। और जो कि हम लेके नहीं चले थे, हम लेके चले थे कि एक्स और वाई डिफरेंट डिफरेंट तुम्हारी इक्विवेलेंस क्लासेस हैं। ओके, यहाँ पे हम लेके चले थे कि इक्विवेलेंस क्लास ऑफ एक्स इज नॉट इक्वल टू इक्विवेलेंस क्लास ऑफ वाई। सो अब हम क्या करेंगे कि हम कलेक्शन बनाएंगे इक्विवेलेंस क्लास ऑफ एक्स such that x belongs to x. I will and in this set will not repeat the equivalence classes. Okay, so if x and z have the same equivalence classes, so I'll just put x in there. Okay, not z, because it is a set, so I can't repeat the elements. Okay, so x and z are equal to, I have to put only one, x or z. Okay, so this collection is a partition, because every two equivalence classes is phi, and union of equivalence classes equal to x. So this is a partition. Now can we define a relation from a partition? Can we define a relation from a partition? The answer is yes. But how? Let x is the set, collection is C, okay, and the collection is, partition is C, okay. C is the collection of all subsets with partition x, okay, of the partition of x. C is the collection of subsets of x, okay. So I'll define a relation x is related to y if x and y belong to the same set. Now here you can see that x is related to x. Why is that? Because x related to x means if x and x belongs to the same subset, which is always true. X and x are always the same set because x is the one element only. Okay, so this is true always for all x only. Okay, so this is reflexive, this relation. Now x related to y imply y related to x. Why? Look, if x and y belongs to the same set, then y and x also belong to the same set. Okay, so this is symmetric also. And similarly you can prove transitive. Okay, if x is related to y and y is related to z, then x should related to z. Okay, if x and y in the same set and y and z in the same set, so x and z should be the same set. Okay, so this is transitive also. And what is this mean? That it is a equivalence relation. So from a relation we can define a partition, and from a partition we can define a relation. So this concept is very useful in the higher mathematics. Okay, where we can define a partition of a set from a relation. Okay, so and this is very useful in group theory, where we can define cosets and all of that. Okay, so that is it for today. Please like, share and subscribe, and if you have any doubts, please comment down. Thank you so much for watching.